All right, so now we've established that this formula is in fact a quadratic equation kind of hiding in plain sight. The question is, how would we solve for t? That's a problem because if we have t and we have t squared, how do we get that untangled? Well, the answer is another blast from the past. Staying with this iteration of the formula, let's see if you remember this one. X equals negative b plus or minus b squared minus 4ac over 2a. That's the quadratic formula. That's the quadratic equation. That's the quadratic formula. That's how you do it. So now let's put our original symbols back in and see how this works. So now we have t equals negative vi plus or minus vi squared minus 4 times 0.5 a times negative s over 2 times 0.5 a. Now that's kind of messy, but it cleans up pretty good. T equals negative vi plus or minus square root of vi squared. Okay, negative times a negative, that's a positive. 4 times 0.5, that's 2as over 2 times 0.5, that's 1 over a, that. Now here's where the punchline comes. If you thought this was the punchline, no, that's just leading up to it. So this is how we would solve time. If we had an object falling off a cliff, we knew how far it was going, we knew what the rate of acceleration was, we knew what the initial velocity was, this is how we would figure out how long it would take to get to where it's going. This is a tried and true piece of physics, just like distance equals rate times time, something you learned back in grade school. This is as hardwired a piece of physics as you could ever hope for. It has been tested beyond numbers. It's safe. Yet, it is in fact a quadratic equation, which means that this is how we solve for t. But if you look at this here and use a little bit of imagination, you can see how it's very possible to get a negative outcome here. It's rather ambiguous. You could have a negative outcome here. So I ask, what the hell is negative time? There is nothing in this equation that suggests a bias for a positive outcome. Mathematically, a negative outcome is every bit as legitimate as a positive outcome. So how do we get out of this mess? This has been an 800-pound gorilla in the room. One of the ways that we do this is this idea. Entropy. Now, I will tell you, there are PhD candidates out there in physics who struggle with this concept. It's elusive. But I'll give you the street fighting definition of entropy. It's this. You can't unfry an egg. You can't unburn a piece of paper. One-way trip. That's the way this universe works. We live in an entropic universe. That is why entropy is referred to as time moves forward in this universe. We live in an entropic universe. That's the basic idea. That tells us which direction time moves at a fundamental level. So, down the road, if I say entropy, you say times arrow. I say times arrow, you say entropy. I say you can't unfry an egg, you say entropy. So there it is. And there are a lot of amazing discoveries out there that can be had just by looking at the arithmetic. Remember what Galileo called this. This is modeling. A mathematical description is a model. It is a part of the scientific method. It's how we make these discoveries. All right. Now, you have on page 70, I believe. Yes, on page 70, there's, in fact, I think you have 2 page 70s in your book. Your homework is to take all of these formulas that we've been discussing and fit them into page 70, and this is where you're going to have a cheat sheet. I do not expect you to memorize formulas. I told you that at the outset. I do expect you to be able to use these formulas. So your assignment is to neatly rig up a cheat sheet using the template on page 70. You might want to use both sides so you can have them right handy. And when we meet again, we're going to use your cheat sheet, and I'm going to walk you through how to do acceleration problems. All right, that takes care of our lesson for today.